Good evening. My name is Scott Ma. I'm an ANZCA counsellor and chair of the Environmental Sustainability Working Group. Thank you all for joining us in tonight's Environmental Sustainability in Anaesthesia webinar, Opportunities for Research and Innovation. I'm hosting this webinar from the traditional lands of the Kaurna people. ANZCA acknowledges the traditional custodians of country throughout Australia and recognises their unique cultural and spiritual relationships to the land, waters and seas, and their rich contribution to society. We pay our respects to ancestors and elders, past, present and emerging. ANZCA also acknowledges and respects Māori as the tangata whenua of Aotearoa and is committed to upholding the principles of Te Tiri o Wātangi, fostering the college's relationship with Māori, supporting Māori fellows and trainees, and striving to improve the health of Māori. I'll quickly run through some housekeeping and technical aspects of this webinar. You will notice that there is a chat box available, and we encourage you to utilise this for general conversation and respectful feedback throughout the webinar. If you have any specific questions for the panellists, please submit them via the Q&A function only. We are recording this webinar tonight, and we will make the content available for college fellows, trainees, and other attendees after the event. It is my great pleasure now to introduce the first presentation from Dr. George Zhong and Professor Ali Abbas. Dr. Zhong is a specialist anaesthetist in Sydney and a member of the Environmental Sustainability Working Group. He has a keen interest in pursuing collaborative research with investigators from other disciplines like engineering. Professor Abbas is a chemical engineer and director of the Waste Transformation Research Hub at the University of Sydney. His interest is in the area of process systems engineering. They will present on the power of cross-disciplinary research. So over to you, George and Ali.
Thank you so much, Scott. Can everyone hear me okay? Wonderful. Thank you so much for inviting me to give this presentation about anaesthesia crossing with chemical engineering. I just want to share with everyone a little bit about my personal journey starting out in research and cross-disciplinary research with respect to sustainability. I have no conflict of interest to declare for this talk. So just to set the scene, anaesthesia has a significant carbon footprint. So out of the entire Australian carbon footprint, healthcare contributes to up to 7% of the total CO2 emission. And anaesthesia, out of that 7%, by volatile gases alone, contributes to 5% of the entire hospital. So I think we as anaesthetists have significant power. When our hand is on the desflurane vaporizer, we immediately control our own carbon footprint. And with power, great power comes great responsibility. I think we have, therefore, not only a responsibility to look after the patient in front of us, but also the responsibility to minimise our carbon footprint while delivering quality care. And I will go on further to argue that with great responsibility, we have an obligation to the future generations to giving them a sustainable, green future. So practically, what can we do? From an individual basis, we can optimise our workflow. We can, while delivering quality care, to be more efficient and more green. At the same time, beyond the individual patients, we can educate ourselves and our peers and also advocate for more efficient greener practice. But today, what I want to focus my talk on is research. Now, traditionally, we think of environmental research involving chemical engineers and environmental scientists, and they're a completely different breed to us as anaesthetists. They speak in different languages, and things like life cycle assessments and circular economy and global warming potential. But whereas us anaesthetists, we speak in terms of propofol, desflurane, and soda lime, and there's significant knowledge barrier. Now, while the environmental engineers and chemical engineers worship people like the Nobel laureates, Kerstin, Molinar, and Rowland, who discovered the free radicals influencing the atmosphere, the ozone, you know, I worship at Scruff888 on Twitter. So with this big gap in knowledge and barrier, here is my story of my leap of faith from anaesthesia to the green side of chemical engineering. So it all started one day in a list with my mentor, Tim McCulloch, doing a vascular list. We asked ourselves the question, well, what is the optimal fresh gas flow during total intravenous anaesthesia? And we all know that for volatile-based anaesthetic, the best gas flow is the lowest gas flow. But what about TIVA? Now, increasing the fresh gas flow will reduce the consumption of soda lime canisters, but at the same time, that becomes more wasteful for medical gases. So where is the balance in terms of the financial, economical, and environmental impact? So on the back of the recycled propofol box, we drew this quick diagram. We set up this rig where we thought maybe we can answer this question by ventilating a test lung with a CO2 inflow to mimic a real patient. So in the next theatre, we quickly set up this rig and we went on to use an anaesthetic machine, both Draeger and G, to ventilate soda lime canisters to exhaustion for hundreds of hours, repeated at fresh gas flows of 1, 2, 4, and 6. And what we found is as you increase your fresh gas flow, and this is known from before, the soda lime canister time to exhaustion increased significantly, especially between 4 and 6. We can see that soda lime canisters onto exhaustion can last hundreds of hours. Quickly putting in the financial aspect to it, going from a fresh gas flow of 1 to 4, more than half the running costs, marginal cost of combined soda lime and medical gas, and further increasing it to 6 reduces the cost by less than 10%. So that answers the economic side of things. Definitively, high flow TIVA saves money. But as Jessie J says, it's not about money. What about the penguins and the environment? And this is where it's way beyond my level of understanding. So what do I do? I have no idea about how to do environmental assessment. So I will do what everyone will do in this situation, and that's ask Google. So I essentially Googled every professor in Sydney who's experienced in life cycle assessment and wrote an email to all of them. And Professor Abbas very kindly wrote back and invited me to his office and explained to me in great detail all about his work and what exactly is a life cycle assessment. But taking this one further, him and his team, within the time course of a month, answered our question, performed a complete, comprehensive life cycle assessment of our problem. So here is our main finding, is that increasing fresh gas flow from 1 litre per minute to 4 litres per minute during TIVA leads to a 5% reduction in the global the CO2 emission as a result. With this combined effort between anaesthesia and chemical engineering, that led to our publication recently in the British Journal of Anaesthesia. So this study is just the beginning. Amongst anaesthesia research and sustainability research, there's a significant increase in recent years of interests, and a lot of them involve cross-disciplinary collaboration. So beyond just this small paper in the BJA, what have I learned? I've learned so much about mutual learning into the fields of chemical engineering, what they can do in terms of environmental analysis. And this has also led to ongoing collaboration with them in further projects to minimize our carbon footprint. And also, I believe these research is very impactful and translational from the benchtop to our bedside daily practice. So to answer the question I posed at the beginning of my talk, anaesthesia multiplied by chemical engineering, an answer to that is sustainability. So with that, I want to pass over to Professor Abbas to enlighten us about some of the work that they can do and how they can, their side of the story in collaborating with us anaesthetists. Thank you very much.
I wonder if you can hear me and see the screen. Okay, great. So thank you, George. And I continue the story, the lovely story of how we got together to solve a problem in the medical space. And let me introduce myself first and where I come from at the Waste Transformation Research Hub at the University of Sydney, where we do work in green technology, waste resources and circular economy. So I'm more on the engineering side of things, but I do want to shed a little bit of early discussion on the waste problem, the environmental sustainability issues, the sort of perspective we have in society. And with this data in front of us here, you could see how the economic growth of economies and countries is very much correlated with the waste production. In today's webinar, we produced some 400 or more than 400 kilograms just from this contribution from the people attending the webinar. You could calculate based on this how many people are attending. So it's a little bit of a equation there. The growth rate of waste generation is rapidly rising. It's at the rate of about 6 times the population growth. This is Australia's situation. This is the same all over the world. It's a big problem everywhere. It's a sustainability challenge. And in Australia, for example, we will need, if we increase the recovery rate, recycling rate from 60% to say 95%, we're going to need some 2,700 facilities in 2036 to deal with all the waste that we're generating. So we need to think differently about waste and the environment. We need to start to think about circularity, and there is a big circularity gap. At the moment, only about 9% circular. The economy is about 9% circular. I mean, maybe recently a little bit more than that, but it's still far off from where we need to be. And of course, there are many drivers for this. Some are political, some are also, of course, driven by social aspects and so on. So it's all really a bit of a wicked problem. There's been a lot of discussion on circular economy. Some of you might have heard about it. It's emerging in Australia. We've had some good development in recent years, but internationally, the Ellen MacArthur Foundation is leading this and talking about this as designing out waste and pollution. And I like that a lot, because design is for me the most important step in solving the problem. We want to design, and we need to design products that are better suited for circulation, easier to disassemble, easier to reuse rather than recycle. So certainly circular economy is not recycling as we would define it. The linear economy really is about take, make, and dispose. That's kind of a diagram on the left showing us that. The circular economy, illustrated recently by the New South Wales EPA in their circular economy policy statement recently released, is about circulations. All these different circles about sharing, repairing, reselling, reusing. And there is, of course, the recycling still there, as I said, but essentially we are talking much more about reuse and repurposing of materials and products. Where is medical waste in all this? That's a question we ask, and I relate that to tonight's discussion. We pulled together some numbers here. Essentially, this is economically a big business in terms of dollars. It's a big market, the medical waste business. But also in terms of emissions, we have quite some significant emissions from the health sector, from the medical waste sector. And this is growing at a cumulative average growth rate of about 6%. So very similar to the Australian growth rate of waste generation. Around the world, also, there are different rates of growth for this market, medical waste management market. But here, this is interesting. In the medical waste, or in the medical health sector, we are focused a lot on reliability, delivering healthcare at 100%. There's no compromise with that. So we less talk about the methods of dealing with the waste. But here you can see the diagram. Incineration, for example, is the key technology used for dealing with waste, amongst others, autoclaving and chemical treatment and so on. So we've taken up the circular economy as an overarching theme in the Waste Transformation Research Hub, which is where I direct that at the University of Sydney, focusing on water, wastewater, carbon and plastics, minerals and e-waste, and many other research topics that we cover here with many industry partners and research collaborations with academics to really solve the waste challenge and define circular pathways, business pathways. So please visit the Waste Hub's website to get more information. How do we do this? I was asked to speak tonight and in more generic terms, and I thought maybe it's good if I explain a little bit about the engineering aspects and how we do things in engineering, and specifically in my area of expertise, process systems engineering, which is much focused on developing models and optimization algorithms and understanding the data and big data and so on. All of that helps us to operate better, to control better the systems and the equipment, and in a chemical engineering sense. But these actually transcend all the way to biomedical systems, such as controlled automation of glucose injection pumps and things like that. So it's quite interesting that I'll later how anesthesia machine is also a system as we talk about it. So PSE approach is motivated by the big drivers out there, the energy, health, and chemicals, waste, water, all of these sectors. We're industry agnostic about these systems, and we approach it through this model-based approach. But also we look at energy specifically and materials, and energy here on the left showing how much energy is going to be required and materials for the production of renewable technology. Of course, energy is important in hospitals, very critical operations. Materials, plastics, $6 trillion business that also feeds in the healthcare sector as well. We go back to circular economy. We held a conference in 2018. In that conference, we really learned why circular economy is not recycling, but rather much more about design. This is what we got feedback from the attendees at that conference. So the linear economy is there. The design aspect of the linear economy, that step is early on, upfront, very important for the entire life cycle of products. So how do we do this? We do this multi-scalar approach from molecular level, atom scale level, and we take this up to equipment level, all the way to systems level and plant operation. But also we think about products as systems in their own right as well. Plastic bag, in fact, is a system. So we talk about its life cycle from acquisition from nature all the way to packaging and disposal. We also consider not only the product or the material in its own little boundary, the molecular level, we consider it at the different multi-scales, and we optimize at the larger scale, and also with integration with the market and the other systems like the weather system. In this way, we can get closer to the global optimum for the different products that we are designing, that we are producing in the market. We use a lot of different variety of software for doing this, but importantly, these are engineering software. This CIMA Pro, for example, is one such software that one can use for calculating environmental impacts, which is what we used for the study with George. On top of that, we put in the circular design objectives. We develop algorithms that are built for operation rather than just simple design of lab scale metrics. We really look at it at the operational level. And importantly, I highlight here how the circular design objectives can lead us to better products and better systems that we can use in the healthcare sector as well. This circular economy certification proposition, which is saying that we should scan through and filter through any products that could enter the market, the economy, that are containing bad chemicals in their process of manufacture. And in this way, we would certify products, and that could be what the designers take first up early on in their consideration when they are designing products. So circular economy and the healthcare sector, or the health sector, medical sector, there are tremendous opportunities here. And I've been looking at them. We've started recently on this direction as a strategic area for our work, where we are thinking how important it is for us to cover the healthcare sector from an engineering circular economy perspective, essentially inspired by the connection with George and the work that we've done. So you could see all these different areas that the healthcare sector could benefit from this type of circular economy, PSE or engineering approach to solving the problems. Waste and emissions is a sustainability challenge. We've been looking at emissions for a long time in engineering, looking at different processes where carbon dioxide emissions, because of the greenhouse gas problem, and solving this problem for the energy sector. But from a life cycle analysis perspective, which is perhaps more focused on the discussion tonight, is the cradle to grave approach to doing things and on modeling that. Essentially, this is the approach that we've used, and the impact measure we have used is the kilograms of CO2 equivalent that's emitted. And there, if people are interested, there is a ISO standard 14040 that describes a protocol for carrying out a life cycle assessment, which is comprised of the definition, several steps, the definition, goal, and scope, including the boundary definition, the inventory analysis, the impact assessment, and the interpretation and evaluation. So this is, I guess, an important sequence of steps that's a standard set of steps that one can use for analyzing or assessing any product on the market in terms of its life cycle impacts, which considers all steps in the life cycle of a product, the raw material acquisition, the manufacturing, as well as the consumption, the end of life phase, but also the logistics, transport that comes along the way with it. With the anesthesia machine operation, we considered the functional unit, which is a key measure. It's the kind of KPI that one targets for any particular product. In this case, we targeted the hour or the time, the unit of the machine operation. And as shown before by George, there is this system boundary here that we had modeled and developed. That's the kind of definition one needs to make. Otherwise, you can blow this out. You need to create a boundary for modeling the system that you're working with. And in this case, we covered the production of the absorbent, the plastic in the canister here that's used in the anesthesia machine, and all the other materials involved. So we kind of done an inventory of all the materials that are used in the manufacture and transportation and all activities, steps in the manufacture of this canister, the absorption canister in anesthesia machine. So it was very interesting for me to learn about the anesthesia machines. When I first looked at it with George, when I visited his at the hospital, at the clinic, you could see this kind of diagram, a basic breathing circuit, but then you could also look at it from an engineering perspective. You look at it in this type of process flow diagram is what we call it in engineering, chemical engineering. And there is also one further level of complexity in these diagrams, process and instrumentation diagram, which really goes down to much higher level of description of the process flows, the valves, the sensors, the instrumentation. So what I wanted to say earlier is that this machine, the anesthesia machine, is essentially a chemical plant. It's got all the items and components that any chemical plant has, all compacted within a small unit, the anesthesia machine itself. So it was exciting to see that, and we're still talking to George and team at the hospital about how else we could improve anesthesia operation. So back to LCA of the anesthesia machine. The modeling work that we've done for this paper that we've published in the British Journal of Anesthesia had to create a model, and that model comes with assumptions, just like any other model. So we are no exception. We make assumptions, and some of them are listed here. I think it's probably wise if I keep moving on and I refer you to the paper if you'd like to go into the details of these assumptions and the modeling. But importantly to mention is that there is a database in this LCA software that sits behind the calculation engine, the EcoInvent database in this case, which has all the information from emissions impact information that one needs all in one place, and it allows us to rapidly develop these models. And these are graphically illustrated in Sankey diagrams as an example on the right here, where the size of these streams indicates how big those emissions are, for example, relative to other streams. And the blocks are essentially the steps taken there. There's a lot of other challenges that engineers and the healthcare sector can work together on. The data challenge is enormous in the waste sector. We have recognized that. We have started to develop a solution for that, and that solution is now ready to go in an alpha version, a software online in the cloud version called the Waste Atlas, which we are rolling out. So if you're interested in this, we also would be very interested to talk with you on developing this for the healthcare sector. It's geospatial. It allows you to zoom in and drill down into geographical locations where the waste is, where it's generated, the quality of the waste, the type of waste, and the volumes of the waste. I'm wrapping up now, and I also say the same message that George had said. It's an excellent cross-disciplinary opportunity. Collaboration has been fantastic to work with George, but also I highlight one thing here, translational research. There are great opportunities in the medical waste, new technologies we're working on, for example, in very, very high temperature decomposition of the waste at some 3,000 degrees Celsius, where we will turn everything down to molecular blocks. So essentially we can completely decontaminate as well as rid of the medical waste, but also recover resources out of it. So there's tremendous opportunities in there, in the sensing, nanosensors, and so on. So it's an excellent collaboration. Anesthesia and chemical engineering is essentially overdue to be collaborating together to solve this sustainability challenge. And I want to also acknowledge the team members who have contributed to this study, particularly Joseph Jones, who's done some background work, good background work on the LCA study, Jesslyn, Georgina, and Jonathan, who have helped also with the LCA and also the presentation slides tonight. And thank you very much. But I will also finish off with this slide here. Next week, there is the Australian Circular Economy Conference, and there are a couple of sessions in this conference on the health sector. So please do look at the Australian Circular Economy website and the program. And I thank you and the organizers for this opportunity to speak tonight, and thank all the audience.
Thank you, George and Ali, and thanks to those who have already started sharing their learnings on Twitter using the hashtag ENVSUS20. Now we'll move on to the next presentation. I'd like to introduce Dr. Jess Davies and Dr. Sophia Grobler. Dr. Davies and Dr. Grobler are provisional fellow trainees, both currently based at the Royal Darwin Hospital. They are co-founders of TRASH, the trainee-led research and audit in Anaesthesia for Sustainability in Healthcare group. Over to you, Jess and Sophia.
Hi, thank you for having us. As Scott said, I'm Jess Davies.
And I'm Sophia Grobler.
And we're both provisional fellows in anaesthetics, and we're currently at Royal Darwin Hospital for another couple of months. And we're thrilled to be invited here. And first of all, just like to acknowledge that we are on Larrakia land. They're the traditional owners of the Darwin region, and we pay our respects to the elders past, present and emerging. And we have 15 minutes. We're going to explain a little bit about what TRASH is, what we've got up to and what we have planned. And we hope that you find it inspiring and can take something from it today.
Thanks. Yeah, so last year we started a research network and we called it TRASH, which stands for Trainee-led Research and Audit in Anaesthesia for Sustainability in Healthcare.
And our motto is that we believe small changes can make a big difference. And through collaborative research and quality improvement projects, we want to create a more sustainable operating environment, but remain committed to maintaining those high standards of patient safety in Australia and New Zealand. It's just that we think that this can be done in a less wasteful manner.
So we originally created TRASH to provide a way for trainees to become proactive in sustainable practice, using their ANSCO scholar role. And that's because research has shown us that culture change requires engagement, education, and advocacy, as been seen in the previous slides as well. And that is why the scholar role fits quite nicely with our goals, as it requires, one, engagement by the trainee, then execution of a project, and then presentation to the department. Plus, it widens the evidence base for sustainable practices.
So we think TRASH is an example of health systems research network, where our projects are a combination of improvement and implementation science. And we've specifically designed our projects to be simple and achievable by any trainee, and something that could be replicated in any hospital anywhere. And as we heard, tackling climate change is so complex and overwhelming sometimes. So we're just taking one tiny part and seeing whether we can do something about it.
So our first project was a pilot cleanup theatre day in March 2020. And this was inspired by Cleanup Australia Day that many of you would already be familiar with. Our hypothesis was that a collaborative small change using the reduce, reuse or recycle principle could make a big difference. And we decided to focus on the reduce part, as reducing an item's use is the most important of the three. Because firstly, it reduces waste going to the landfill or the incinerator. And secondly, it reduces the carbon footprint created by producing the item in the first place, like the linear economies that Ali was talking about. And that's from the raw materials to processing, to manufacturing, to transportation.
And we wanted to pick a single, visible, high-use item that's easy to measure, easy to reduce across multiple sites, but without compromising any patient care. And that's how we came up with reduced bluey use, which was our 2020 theme.
Now, we do acknowledge that blueys have a very important function. It is to wick moisture away from a patient's skin to prevent contact dermatitis and pressure sores. But how many times do you use it not for that purpose?
And our aim was to educate departments regarding the quantity of blueys being used, encourage reflection and discussions, and have some engagement on the uses of blueys other than its intended purpose. And we thought that that would generate some discussions and find some department-based solutions for reducing or replacing a blueys use that were suited to a specific department.
Now, just before we continue, just have a guess at how many blueys you think your hospital's operating theatres might use in a year. And maybe just write it down whilst we're talking, because the number might surprise you. And then also reflect on all the ways we use blueys in our day-to-day practice. We're going to post a little 2-minute short 2-minute survey on the bluey use, and we'll be really grateful if you can submit that during the course of the webinar. And we'll post that link in the comment sections a bit later.
So we put a call out and we had 7 trainees run Clean Up Theatres Day in 7 different hospitals across Australia, which we were really happy with. The trashies found that in a single year, a range of 15,600 blueys for a 3-theatre complex and up to 96,000 blueys for a 14-theatre complex were being used in one single year, and that was pre-COVID. And our trainees found lots of innovative solutions to either reduce bluey use altogether, for example, not using it as a tablecloth on your anaesthetic trolley, or to replace its use with a less wasteful alternative. And some of those things turned out to be a paper roll to mop up spills or to wrap up a contaminated airway after you extubate.
So to illustrate the power of what a small change can do and what a big difference it can make if we just work collaboratively, we're going to do a thought experiment. There are nearly 1,500 operating theatres in Australia and New Zealand. And if we extrapolate the numbers from our findings, we estimate that between 7.5 and 10 million blueys will be going to landfill or get incinerated each year. And that's not including bluey use in other parts of the hospital. And that's also the carbon footprint of 7.5 to 10 million blueys. The sourcing and processing of bluey's 3 components include agriculture, mining, drilling, fracking, and the chemical processing requires temperatures exceeding 850 degrees, pressures of 110 bars, and there are several stages before the final components can be assembled. And so we were feeling like investigative journalists, and we rang an Australian-based bluey company and traced the life cycle of the 3 components. And we discovered that 12 countries were involved in the making of a bluey. Between each of these 12 countries, there will also be a significant transport footprint too. And one of our future projects is to work out what that life cycle analysis is, as Ali has mentioned in his previous presentation. We don't have the exact figures yet, but it is easy to see that the bluey contributes to more environmental problems, not just landfill or incineration.
And importantly, there are economic benefits to reducing bluey use as well. So in one Victorian theatre complex, they spent nearly $13,500 on just bluey procurement in 1 year in 2018 and 19. And if we work out the cost per bluey, then operating theatres in Australia and New Zealand will be spending between $1.2 and $1.7 million on blueys alone per year. Plus, we can't recycle a bluey, they're not compostable, even when they're marketed as eco-friendly. It's a hoax. The same Victorian hospital from our example spent $1.5 million on waste disposal last year. So we think the contribution of blueies is significant. And many blueies will be categorised as a clinical waste in some hospitals, which is 4 times more expensive than general waste, and if incinerated, 5 times more expensive. So waste disposal costs are difficult to extrapolate as there are many factors involved, and it also depends on the region. But we made some basic calculations based on a clean bluey and found that waste disposal will cost Australia and New Zealand theatres anything between $100,000 and $600,000 per year.
So to conclude our thought experiment, if every theatre in Australia and New Zealand can produce 1 bluey per day, that's just 1 bluey, we could save about 500,000 blueys from being manufactured, transported and disposed of in the environment. And that will equate to a cost saving of nearly $1,000 just in procurement, and at least another 1,000 in waste disposal.
So this is just one example of how a small change of 1 bluey per day per theatre could make a big difference environmentally and economically, but only if we work collaboratively. And we have precedents for this. Anaesthetists worked to remove the Clausen ring from clear face masks in the UK, which saved around 2 grams of plastic per day in one hospital, demonstrating that clinicians have an ability to change products and processes from the ground up.
We learned quite a lot from our pilot experience and decided to create a procurement audit blueprints that could be used by trainees for any project idea. And this rests on the hypothesis that reducing a single measurable item across multiple sites can lead to a sizable change. And when many trainees do the same project in their own department, we may start to see big numbers. And anaesthetists in Australia and New Zealand already have a strong history of large multi-centre research efforts, and we are drawing on those same principles of collaboration to conduct healthcare systems research.
And an important finding of our pilot is that the projects just don't work when we remain in an anaesthetic silo, as George and Ali have explained as well. Involvement and engagement of multidisciplinary theatre staff are mission critical, and a grassroots movement is only possible with buy-in from all those grasses in that lawn. And we hope that the trainees undertaking our projects become skilled in collaboration and teamwork from the outset, which is a great skill to have. And I hope they recognise the necessity of involving nurses, techs, surgeons, and all groups in the operating theatre if they're going to have an engaging project.
So we're just going to demonstrate one of our audit blueprints. We are currently running a trainee-led multi-centre audit on perioperative paracetamol use. And we are drawing on our principles of collaboration and a simple, achievable project to reduce a single item. And in this case, it's going to be intravenous paracetamol. And when each trainee undertakes the same audit in different hospitals and then collaborates to share the information, we generate a much bigger pool of information to work with.
So quickly, some background. I'm sure you've all used paracetamol. It's nothing new, but compared with IV paracetamol, oral paracetamol has 100% bioavailability and a similar efficacy. We already know about the cost benefits of choosing oral paracetamol. In our hospital, it's IV is 82 times more expensive than an equivalent oral dose. But when we apply a sustainability lens, we find IV dosing produces more waste because of the vial itself, packaging, sometimes an extra giving set, plus the carbon footprint associated with sterilisation and waste. So our hypothesis is that avoiding an IV dose will result in reduced waste and reduced carbon footprint if we replace that IV dose with an oral pre-med. So there were 2.6 million surgical interventions in Australia between 2018 and 2019. Many of those would have received paracetamol. And imagine how much waste we could reduce by giving elective patients some oral paracetamol preoperatively rather than IV paracetamol.
And there's also the economic cost of waste disposal to consider. Firstly, per volume of waste, 1 glass vial is probably equivalent to about 25 oral blister pack doses. And some hospitals use loose tablets, which will equate to an even greater waste volume saving. And secondly, because glass IV paracetamol vials are sometimes disposed of in shaft bins in some hospitals, which then gets incinerated, there are huge cost savings to be made, since we have previously mentioned that incineration is 5 times more expensive than general waste and 10 times more expensive than recycled waste.
So you can think of our projects like a Keep Cup, a simple, achievable intervention that has little consequence on your quality of life, but you're avoiding the manufacturing, transportation, and wastage of at least 365 coffee cups per year. and trash is applying those same principles to healthcare.
So our model will likely change as we learn more and we grow, but we are flexible and adaptable, and being trainee-led, we have a steady stream of enthusiastic trainees to participate. And one of our goals is for each multi-center project to have a pilot study done first. And now this is the part where we call upon you. So we know that so many of you have already done some great things in your departments, and we want your ideas, and we want to turn that into the next pilot study so we can create a collaborative multi-site research project.
So one of the main challenges in research is to translate research into clinical practice, which we know is really hard. But we also know that there is already a body of evidence on sustainable practices already, much of which is curated by the ANZCA Library Guide.
And our efforts to translate research to practice include setting up a social media presence that allows trainees to connect and share information. And we have summarized some existing papers and made Twitter tiles, infographics and downloadable posters for our website to encourage trainees to share the existing body of evidence via the social media, or to inspire informal conversation during daily practice, and maybe to present articles in Journal Club. And we are hoping that new research ideas might also follow, and trainees will then have somewhere to turn to for support and connection.
So we're also interested in looking at the reasons behind clinicians' choices and how we can influence them to make a more sustainable choice. And often these get tied up with cost savings, but in battling climate change and waste production, we have to remain scientific and evidence-based, and we have to continue to build this evidence. And I think critical to our success so far is that Trash's projects are done by trainees, perhaps reflective of a generational shift in our approach to resources. And our researchers are clinicians working on the job. They're leading a grassroots change. Clinicians have an understanding of what constitutes good patient care, and also what practices can be more lean and more green.
Plus, trainees rotate between departments, allowing the opportunity for shared learning and bringing new ideas. And given that the time taken to see evidence-based practice change clinical practice is 17 years, with the help of social media, we are hoping that that will be expedited with a groundswell of rotating trainees implement changes at each hospital, and forming a strong and increasingly loud voice of environmental and financial reason.
And I think by being a grassroots research network made up of frontline workers, we are all in a unique position, as George said, to translate our research into clinical practice from the outset. And the advantage of trainees rotating through departments is that our shared learning is possible, and that is really critical to any sort of success. The disadvantages are that some ideas might fizzle with time, and so we need ongoing champions in departments, which may be trainees who've been part of Trash, or perhaps if you're a member of staff, whether a consultant, maybe you're a nurse or a tech, then we want Trash mentors to be present in hospitals to be able to support a project. And we would love for ANZCA to encourage departments to implement dedicated sustainability officers to drive the change forwards.
And in the last year, we've worked hard to build an infrastructure to connect members of our network and to share information by creating a website and curating a Twitter account. We've also created a steering committee, and you can see them there sporting the environmentally themed hats that we made to raise funds for the cost of our website and the program we used to make the infographics. And we found some support from the University of Melbourne and the Centre for Integrated Critical Care, which has given us access to a secure, centralised database from which we can conduct our research and analyse our results.
And because many of us have a common goal, probably everyone in this webinar, which is to protect the planet whilst looking after our patients, we have found that people in sustainability research have a culture of being supportive and collaborative rather than competitive. And we've established relationships across the pond with Greener Anaesthesia Sustainability Project, which is called GASP in the UK, and with the Gas and Greener group in Yale in the US. And we're also working on a collaborative Cleanup Theatres Day next year with a surgical trainee research network called Veritas. And our Cleanup Theatres Day will be on April 22nd, 2021.
So we really hope that Trash continues to grow and to remain trainee-led. And we are working to get Trash to a stage that we can hand over to our trainees to take it forward. And when we started, we limited involvement to just trainees, mostly just for the workload. But now we've come a long way and we welcome everyone, anaesthetists, trainees, anyone interested in sustainable healthcare, because we recognize the importance of multidisciplinary teams. And really, we all live on the same planet, and our collective actions now can make a big difference to all of our futures.
And thank you so much for the invitation to be a part of this webinar. We are really honoured and humbled by it, and look forward to some questions, and especially to engaging with many of you outside of this webinar, either on Twitter or via our website. And I'll hand over to Scott to lead the Q&A session.
Thank you, Jess and Sophia. Now we'll move on to the Q&A session, and I want to welcome to the panel Associate Professor Kerstin Wyssusek, Head of the Department of Anaesthesia and Perioperative Medicine at the Royal Brisbane and Women's Hospital, Dr. Forbes McGain, Specialist Anaesthetist and Intensive Care Physician at Western Health Melbourne, and Dr. Rob Burrell, Specialist Anaesthetist based in Auckland and Chair of the Sustainability Group of the New Zealand Society of Anaesthetists. Firstly, there was a question that was posted by Jonathan Harris. He would like to learn how to perform a good life cycle analysis. I thought, Sophia, a question for you. How did you approach the LCA for the Bluey?
So with difficulty and coming to the conclusion that it's a science within itself. And so what we did was we first, I rang around lots of different companies and finding out, and it was a bit of a trial to find out where each of the different components are coming from. I then did a literature search to see if anyone has done an equivalent life cycle analysis, which I can then extrapolate as well. But I've come to the conclusion that we actually need to do it with a life cycle analysis. And so, for example, we are working with Jodie Sherman at Yale for life cycle analysis with paracetamol. Her group can do that. And we're also hoping for the Bluey that we can work through ANSCA and perhaps apply for a grant or something that we can do a series of life cycle analysis for a number of products.
Thank you. And Ali, it seems like you really do need an engineering degree to perform a life cycle analysis, but do you have any tips on how to get started?
Yes, I think it's always good to start with a literature review in any research. There probably are life cycle analysis for a lot of products and a lot of materials out there. That's always the starting point. But then I guess, as mentioned, the idea of a life cycle analysis, it's a modeling exercise. So we always tell people with modeling, the models are just as good as the assumptions that hold those models up. So the assumptions and setting up those assumptions is in its own right is, I guess, one of the difficult steps. And therefore you need to understand the system, like the anesthesia machine system. You need to understand what and how it works, what materials go into the particular product, the system, and understanding, drilling down into all the components that are involved. So whether it's the adsorbent, whether it's the plastic material that's there, you've got to come down to the level to understand all the types of materials and the different types of plastics perhaps that are involved. And then you need to quantify their volumes, the amounts basically. And going forward, step by step, it's kind of building that boundary around the system and understanding where your boundary limits are, because that's again, it's a big assumption regarding your boundary. Then you'll make assumptions about transport and so on. The details are there in many of these protocols for the development of LCAs, and I think it's wise to cooperate with experts in the field, but it's not something that's very, very difficult. I am sure that with a little bit of effort, there's you know, it becomes something that's easier to understand and better to work with. So there's software there and so on. So it's all very well developed. Yeah, I'll leave it at that. I think I'm happy to work with people if they have those types of fun problems to solve in the health sector. So please reach out.
Thank you. Kerstin, a question for you from about the role of manufacturers and distributors. Now, I know that you have been involved in some work, publishing some work on PET plastics, and many of our consumables are wrapped or created from these plastics. The question is, how do you balance the role of the manufacturers in making a profit from their products, but working towards a circular economy? So do we need better stewardship of the products, and do we need government policy to drive this change? What are your thoughts on that?
Yes, Scott, thanks for inviting me. We need all of the above. Everything you mentioned, Scott, is needed. So product stewardship is a buzzword, as is extended producer responsibility. And unfortunately, in Australia, that's not legislated. In 2011, there was a federal government act announced, which is the Stewardship Act, and this is only partially mandated. So currently, there's only a voluntary and partially industry-funded product stewardship scheme happening in Australia, which is mainly around tires, paint, TVs and mattresses and printer cartridges. There's no producer responsibility in the healthcare industry whatsoever, apart from Baxter. I think Baxter is the first and one and only company at the moment who has taken responsibility for their product and has partnered with Vinyl Australia to introduce the PVC recovery scheme. But, you know, extended producer responsibility is actually a very cost-effective way to minimize the waste going to landfill and products harming the environment in our health. But we would like to see the government to be stronger on their mandate on responsibility in source of production, where the companies need to look after the recovery and reuse of their products. And as you said, in healthcare, everything is very, very expensive. So I believe there is great scope there for the healthcare industry to held accountable for their own product recovery. So it's placing responsibility right back at the production line. I think there's a little bit hope out there, as in 2020, just this year, the Australian Packaging Covenant announced that by 2025, they would like to see that 100% of all packaging in Australia is either recycled, reused or compostable. So, and as ANZCA and the Sustainability Group, we have sort of started discussions with the Packaging Covenant. So I'm very hopeful we will achieve great results moving forward.
Thank you, Kerstin. Part of the role of research is the ability to translate it into practice. Now, Rob, at your hospital, you have a sustainability officer that would be able to assist you in translating the research into practice. What are your thoughts of the benefits of having a sustainability officer in the hospital?
Tēnā koutou katoa. Thanks, Scott. I must say the profession seems to be in really good hands, having listened to the talks this evening. It's really inspiring. Yeah, New Zealand's in a special place right now. Yesterday, the government announced that the public sector would have to be carbon zero by 2025. So we're going to go from having about half of our hospitals having sustainability officers to all of them very quickly, I think. Doctors love trying to take their little pieces of research or their big pieces of research and turn them into something practical that they can use to change what they do. So I think we're really keen to translate research into practice, but we really struggle with it. And that's because we all work in silos. That's because we all have clinical jobs that usually fill our lives. That's because we don't speak the language of the bean counters, the people who run the hospital. We don't speak the same language. We speak a clinical language, and they talk about money and outputs and things that I don't understand. So what you really need, I think, is a friend. You need a mate, somebody who can cross silos, somebody who can speak the right language, somebody who can keep knocking on the door over and over and over, and somebody who can help you form a network within your organization. So all the different people you need to line up to make a change can make a change together. And I must say the relationship we've had with our past or recently, the lady who's recently left us, who was our sustainability officer, was fabulous. It was always nice to have somebody you could talk to when you were feeling a bit down, because she was up, and when she had a few losses, we cheer her up as well. And our new one's going to be just the same and just as good, and they're a fantastic person to have if you're lucky enough to get one.
Thanks, Rob. Another question for Forbes and Kerstin. Now, one of the biggest challenges is buy-in from hospital executive. Now, Forbes, I'm sure you've encountered issues translating some of your work into practice, and Kerstin, as a head of department, how do you engage your hospital executive about sustainability issues?
Kerstin, would you like to talk first?
Yeah, I can. So I think Rob mentioned a very, very important aspect, which is money. So administrators speak a different language, as Rob said, and they are interested in savings and in money. So demonstrating that the organization can save money in recycling and reducing and reusing products will get their attention, but you need to be very, 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 very consistent, and perseverance is needed. It is really needing to find a friend. You need to find someone in your waste management committee, or even your executive director, someone above you taking you further, and then consistently persisting on being heard. It is a long, long, long road. There's many roadblocks normally, but great to hear that New Zealand is now storming forward for zero carbon emission in 25 years, which is fantastic. So I suppose we will all need to follow in Australia, and be busy. And in Queensland, we introduced a waste levy last year. So all companies need to pay a fine if they don't recycle. And recycling is just up and running everywhere, including hospitals. So I think, you know, governments play a big part, and that will drive your activities, and you will be heard. I think it's great initiatives out there that the administrators are forced to listen to us.
What are your thoughts, Forbes?
Thanks, Scott. So I recall quite clearly the manager of the operating room services saying to us, we're going to go to disposables for everything, for anaesthetic equipment, circuits, face masks, everything else. And most of the audience would be interested to know that at Western Health in Melbourne, we actually have reusable circuits, we have reusable face masks, and reusable laryngoscope blades and things like that. So face masks in particular are quite abnormal. Most of the registrars come to me and say, my God, you're using reusables. That's fantastic. We just chuck them all away a few kilometres down the track. So what we did was a lot of hard yards, and I think, in fact, George might have quoted that paper of ours in the British Journal of Anaesthesia a few years ago, which was a comparison of reusable and disposable anaesthetic equipment at the Austin versus the Western. Austin is all disposable, chuck away. And so it was quite interesting. We in terms of saving on the environment, it wasn't very large. It was minimal, if at all. But saving on, it was saving using reusable variants of those common anaesthetic equipment. Saves about $5,000 per operating theatre per annum. So we were saving over $100,000 a year. And that's including all of the costs of, we went through what we call a time and motion study of measuring everything that was going on behind the scenes of how much time it took to reprocess reusable equipment. And so fortunately, we're able to come back to that and say, please don't do that. And we're able to save $100,000 a year. So I think that's what got over the line, Scott. This wasn't the environment by any means, it was the cash. What's interesting though, Scott, is the lack of interest of changing the rest of the universe. No one I know of has converted back to reusable. And I'm doing that deliberately. And I want the audience to go, what about me? We've done this and that'd be great. I want to hear that. Because I think the big missing picture here is translation of research. It's not necessarily a lack of information, although as Sophia rightly mentions, and I'd love to be involved, Sophia, the whole paracetamol study with Jody Sherman is one begging to be done. But yeah, I think that there's a lack of translation of research at the moment.
Thank you. Unfortunately, it's time to end the webinar for this evening. It's been fantastic to have so many people on this webinar. And I would like to thank the speakers and panelists for giving up their time to be part of this event. I hope that all of you tuning in tonight will leave with some new ideas, and I do encourage you all to continue the conversation with your colleagues. One last piece of housekeeping though, you will receive a post-event email with a link to a survey that we would strongly recommend you complete. Your feedback is valued and it will contribute to the future success of webinars hosted by the college. Once again, thank you for taking the time to be here, and I hope to see you again either virtually or in real life very soon. Have a good night.